Even though ChatGPT feels like it's been part of our lives for centuries, you probably haven't even heard of GPT-1, which was released in 2018. Stay tuned with Honformation to discover how ChatGPT, DeepSeek, and similar programs understand everything. The famous software you know as ChatGPT made a huge leap, and GPT-4, the version you can access for $20, entered our lives on March 14, 2023. These events feel like they happened just yesterday. And the wave ChatGPT created spread to other major language models like Claude and Llama, as well as video-generating AIs like Sora and music-generating AIs like Suno, changing everything. But have you ever wondered how all of this actually works? How can a piece of software not only recognize what's in a photo, but also solve a mathematical equation within it and explain the solution to us out loud? Or how can a program write a poem in the style of Shakespeare while also being able to teach a quantum mechanics lesson? What's happening under the hood? Seriously, how does a machine learn anything at all? Let's take a closer look. First, let's explore. What is an algorithm and what sets AI apart from other software? An algorithm is essentially a logical recipe, one that, no matter how many times you input the same data, will always give you the same result. Unlike humans, it doesn't get tired or bored and is almost entirely error-proof. Think about calculators or tools like Excel, or even consider the URL bar you use to browse the web. Imagine typing in Honformation one day, and it randomly opening Wikipedia, then Netflix the next. You wouldn't trust or use that software, right? Or what if your calculator gave you different answers every time for the same equation? Traditional software gives us incredible speed and precision, but its rigid determinism limits the richness of the outcomes it can produce. What makes intelligence fascinating isn't rigidity, it's flexibility and adaptability. To achieve that, we developed probabilistic, statistical tools. And eventually, we arrived at what we now call artificial intelligence. These systems have a more unpredictable nature, but this unpredictability is adjustable and even controllable, allowing them to generate different answers each time while still maintaining a reasonable level of accuracy, despite occasional mistakes like hallucinations. We always say GPT, but what does it stand for? GPT means Generative Pre-trained Transformer. Generative. Contrary to what some claim, these AIs can create original content, not just copy and paste. Pre-trained. They're trained on massive datasets before you even start using them. But why pre-trained and not just trained? Because while they're trained on broad data for general use, they can also be fine-tuned later for specific tasks. This is crucial, especially for specialized professions. Right now, we're using general-purpose AIs that haven't been specifically trained to be doctors or engineers. But imagine when AIs are trained solely for medical purposes or diplomacy and law. That's a future we'll all witness. The last letter T stands for transformer, which is actually the most revolutionary part of GPT. But before we dive into what a transformer is, we need to go even deeper into the basics. A transformer is, at its core, a type of deep learning algorithm. And deep learning is just a more complex version of artificial neural networks. These neural networks are inspired by the structure and function of the human brain. Under a microscope, neurons look complex, but textbooks simplify them. Dendrites, the branches, receive electrical signals from other neurons. These signals cause biochemical changes in the neuron's cell body. If the signal is strong enough, the neuron fires its own electrical signal through its axon. We often visualize these as quick, strong pulses, but in reality, the signals are bioelectrochemical and much subtler. This vast network of neurons allows us to see, hear, think, and even reason. Processes like memory, learning, and forgetting happen as connections between neurons strengthen or weaken over time. You're looking at a simulation of about 4,000 neuron connections, one of the most accurate ever made. What is an artificial neural network? Artificial neural networks, ANNs, are inspired by these biological systems. We often represent them as diagrams with interconnected nodes representing neurons. Input neurons, the green ones, are like our sensory organs, receiving external data. Lines between neurons represent connections, each assigned a weight between 0 and 1. The strength of these connections dictates how much influence one neuron has over another. Each neuron performs a simple mathematical operation. it multiplies the input it receives by the connection weights. Then, it adds a bias term to adjust the activation threshold, similar to how real neurons need a certain level of stimulus to fire. The result isn't always between 0 and 1, so we use a function called sigmoid to normalize the output. Layers in neural networks. In diagrams, each vertical set of neurons represents a layer. Input layer takes in raw data. Hidden layers process and extract patterns. Output layer produces the final result. By stacking multiple hidden layers, we can create complex networks capable of recognizing patterns, translating languages, or even generating images and music. When you compare these artificial networks to real brain scans, the similarities in structure become striking. Of course, there are vast differences between biological brains and machines, but we've already managed to replicate some of the complex behaviors found in nature. So how does an AI actually learn? That's the next big question. How do these artificial networks go from random noise to producing meaningful, intelligent outputs? Machine learning, deep learning, and handwriting. How do neural networks learn things? Let me ask you a simple question. When I show you these letters that look very different from each other, your brain instantly recognizes that they are all the letter A, right? Thanks to neuroscience, we now have a pretty good understanding of how we do this. I won't go into those details here, but imagine you had to give this ability to a machine. What kind of solution would you come up with? One approach could be something called pattern recognition. For example, take a handwritten digit like the number 3. You could enclose it in a box and assign a value between 0 and 1 to each pixel based on its brightness. A fully black pixel would be 0, a fully white one would be 1, and shades of gray would fall somewhere in between. The goal here is to teach the machine to recognize which handwritten digit any given pixel arrangement represents. If we can achieve this, the machine will have learned to read handwriting. To start, we need to convert all the pixel data into inputs for a neural network. Suppose our box is 28 by 28 pixels. That means the input layer of our neural network will need 784 neurons, 28 times 28, each one representing the grayscale value of a single pixel. The output layer will have 10 neurons, each representing one of the digits from 0 to 9. The task of the network is to identify which digit the input image represents by lighting up the corresponding neuron the most. Between the input and output layers, we have hidden layers. These layers help the network learn important features of the handwriting. The number of hidden layers and the number of neurons in each layer are arbitrary. You could have 10 hidden layers if you wanted, and each layer could have 100, 1,000, or even just 5 neurons. But of course, these choices will affect the speed and complexity of your network. Traditionally, networks use 2 hidden layers, but when the number of layers exceeds 3, the network becomes what's known as a deep neural network, which is where the term deep learning comes from. No matter how complex the network is, the core idea remains the same. After passing the input through all the layers, the neuron in the output layer that lights up the most indicates the network's prediction. A well-trained network will usually activate all output neurons to some extent, but the most active one represents its best guess. If you'd like to visualize this network in 3D, it would look like a complex web of interconnected nodes. So how do we train this network? Well, that's exactly what we'll dive into in video number 2. Make sure to subscribe to Honformation and turn on the notification bell so you don't miss it. See you soon.